Hello everyone, welcome to Integrated Math 2. Today we're going to be discussing Notes 4.1 Geometric Mean. Make sure that you write your first and last name in the top of your page with your period number in that top right there. Once again, we're talking and dealing with geometric mean, not to be confused with arithmetic mean. So the geometric mean of two numbers is the positive square root of their product. So basically, we're going to have the following. I'm going to write it in real fast. So if we get some sort of proportion, and we get a over x is equal to x over b, we can use cross product and get x squared, x times x. So I could go like this, I'll do green. So this times this will equal each other. So on x squared is equal to a times b. But we don't want to solve for x squared, we want to solve for x. So if we find the square root, well then, x will equal the square root of a, b. But we're going to just make it positive. No negatives, all right? So keep it positive. Be happy. Let's continue. So geometric mean. And so we're going to talk about the altitude theorem. So let's write that in. So we have this versus leg. So basically, if we get this right here, that we can make a proportion on, we can understand that, hey look, this x over h will equal h over y. And if we do cross product, we'll get h is equal to the square root of xy. So that's about it. Let's go on. Let's get an example of that. But first, let's do the leg. The Geometric Leg Theorem. So on this one, we could be talking about, hey look, CD is the altitude of the hypotenuse AB of a right triangle ABC, then C over B will equal B over X, or B is equal to the square root of X times C. Or we could do it with the other side. We can understand that we can make this proportion of C over A is equal to A over Y. So then we can make that into our geometric mean. So let's break this down real fast. What's happening is we're creating some of these similar triangles and we're comparing the sides that have equal measures that are going to be proportional, that are going to be dilated. And so when we do this, it creates this geometric mean. All right, let's do an actual example of it in 3, 2, 1. So find the geometric mean between 12 and 15. All right, well, hold up. So remember guys, geometric mean is just, hey, you're going to times it and find the square root. So let's find it. So I know that x will equal the square root. So the geometric mean will equal 12 times 15. Now I'm going to try to do this without using a calculator. Let's see how far I can get. So I know that 12 is 4 times, so I can do square root. 4 times 3, and 15 is 3 times 5. I know I can figure out the square root of 4 will equal 2. So I'm going to say, all right, let's bring that guy out. And there's 2 3s, so I can take one of them out. So now it's 3, 2 times 3, and then I have the square root of 5. Well, I can't figure out the square root of 5, so the best I can do is x is equal to 6 radical 5. And at this point, I'd want to solve for what is the square root of 5 times 6. Alright, so looking at this, I got x, the geometric mean between 12 and 15 is 13.416. But wait, there's more. Like, some of these problems are going to say, hey, keep it as the simplest radical. So we did the intro so that when you're doing this, hey, you can keep that as the answer. You don't need to go on. So what I'd like you to do right now is I'd like you to try to do this one. So I'm going to give you 3, 2, 1. So the geometric mean is going to be x is equal to 15. Why don't you show your work? It's going to be nice because there's no radicals. After you do the work though, there's going to be one right at the very beginning, and then you're going to be able to get rid of it. Alright, let's go on. So example 2. Alright guys, so we're talking about identifying similar right triangles. So if we were actually to break up this large triangle right here, we can break it up into 3 triangles. We have this big one right here, where we have the right angle S. And we have this short one right there. We could say, hey, this is going to be short the leg. We can call this B. So we can call this B right there. We have this long leg right there. So we can call that A. We can break up this whole thing right here and convert it into 2 other triangles right here. So we see this right here. We can see, all right, across from here, we have the hypotenuse. So across the hypotenuse. So we could draw our 3 right triangles right here. And across from this smaller one with the right triangle at T this time, is going to be A. And then this is going to be, we can leave that alone right now, but that would be a certain number. We don't know what number it's going to be, but we could leave it alone. Now this altitude that's cutting it across right here, we can call that H. So we're going to call this one H right here. And so we can figure out each of these little labels, little values, if we can get information regarding the triangle. All right, the last one right here, SR, remember that was B, and then TR, and we'd probably get a number for it later, but this ST right there, that's going to be H. So now we can create, like looking at this, we should probably, when we get something like this, we're probably going to want to make sure that we label our graphs. So let's do the check. Write a similar statement, identify the 3 similar right triangles. So the first step is we have to draw the right triangles. Probably want to have the short leg. Probably going to have the long leg. So let's do it. Now we're going to pause it for a second right here. And I want you to try to finish up for it, okay? In 3, 2, 1. The first thing we're going to do is we're going to try to label the vertices. So let's do it. So looking at this, it looks like my big one is going to be ML. We can call this A. And then looks like my short leg is going to be B. I'm going to call it B. But that's not my vertice. My vertice would be this K right there. And so if we're going to do the Pythagorean Theorem, A squared plus B squared is equal to c squared. So now we have to figure out what are my other two triangles. So the next one, it looks like it's going to be P right here. So I'm going to put P. And it looks like the other triangle is P as well. So PM is going to be short in comparison to this one, P2L. And so now I know that P to M is my height, and I know that ML is A. Now this P, the last one, this little one right here, it looks like it's going to go P to K is my short side. And my long side, my hypotenuse, not my long side, my hypotenuse is K to M. So therefore, P to M is my long leg. Now we don't have these. That would be like this value right here. We call this X and Y. And so every time we have KP, that's equal to X. And every time we have PL, that's equal to Y. So there is that. So now what I want you to do right here, I want you to write in your triangle similarity statement. Which three triangles are similar? I would recommend just starting here and go around in a circle. Make sure you go around in the correct format, either with the clock or against the way. All right, let's go on to the next one. In 3, 2, 1. So let's do using the geometric mean with right triangles. So example 3, we're actually going to use numbers now. Well, why don't we do it? It says find the values of x, y, z. Well, the first thing we have to do is make our triangles. Let's do it. All right, well, I understand that I can figure out the geometric mean of this x right here. So I can draw it out, or, I understand that, hey, look, x is going to equal, the square root of AD times AC. So 8 times 25. So that's going back to the geometric mean leg theorem that we had right up there. Basically, it's saying, all right, this leg is equal to 8, the square root of 8 times 25, or not 25. No, it's A through C, so it's 25 plus 8. Sorry, guys. Forgot about putting it together. But we're going to have x over 8 will equal 25 plus 8, 33 over x. And so it creates this proportion. And then when we solve it, we get the square root of 8 times 25 plus 8. So if we do it, we get x is equal to the square root of 8 times 25 plus 8 times 8. All right, so looking at this, I can now solve this. I get x is equal to, using my calculator, I get the square root of 264. Now, some of you might think, hey, wait, isn't this 8 times 8? Well, yeah, but there's this plus symbol right there, so we can't do that little trick of pulling out things that are multiplying, like 4 times 4. Oh, that square root of 4 times 4 is 4. Can't do it because there's this plus. You have to get rid of all the adding and subtracting. All right, so if I get this, the square root of 264 is going to be 2 rad 66. Well, it's going to be around 16.2. All right, let's go on and figure out y. All right, well, with y we can use the same geometric mean with the leg theorem again. So we're going to say, hey, y is equal to, well, on this one, it's going to be, square root of 25 times 33. Or the 8 plus 20, or the 25 plus 8 right there. So when we multiply that, we're going to get the following. We get the radical of 825, or we get 5 radical 33, which is equal to around 28.7. All right, so now we did x, we did y, now we're going to do z. Now this one, instead of using legs, we're dealing with the altitude. So with the altitude, we're going to figure out using the altitude theorem. So go ahead and look at it real fast. Remember with the altitude theorem, it was like, hey, this part over z is equal to z over 25. Well, if we did our multiplication cross product, we then did square root, we get z is equal to the square root of 8 times 25. Well, on this right here, 4 times 25 is 100. So then 8 times 25 is 200. And so we get z is equal to the square root of 200. Well, I can break this up into the square root of 100 times 2, or z is equal to 10 radical 2. Or, using my calculator, 14.1. So now let's talk about why we can't have negative numbers. Okay, well, can you have negative distances? No. So there's a little hint on that. So it's only going to be positive, not negative. All right, guys. So last problem right here, the check. So remember, you're going to create those proportions, okay? Or you can simply understand that you're going to figure out different things on this. So using this, we should probably figure out what is x using the altitude first. Remember that you're going to do the altitude over 9 is equal to x over 12, which is the altitude, and then solve for your problem. All right. Now I'm going to help you do that, but hold up a second. I'm going to give you the answers. I want you to try to figure it out using your work. In 3, 2, 1. All right, guys. So the answers are 16, 20, and 15. But remember, you do not get credit unless you show some work. So what I would like you to do is set up your problems and let's go. All right, guys. I'll see you in class. Bye.